to True Projects. In this video, we are going to explain about the project that is an efficient malware detection approach based on machine learning feature influence techniques for resource constrained devices. So before getting into the execution, first let us understand what is this project about. As we use computers and smart devices more and more in our daily lives, these systems are becoming easier targets for cyber attacks. One of the biggest threats comes from malware, which is short for malicious software. Malware is designed to harm your computer or network, either by damaging files, stealing information, or taking control of your system without permission. And there are many types of malware, each working in a different way. For example, viruses can spread by infecting other files, Trojans they disguise themselves as legitimate programs to trick users, spyware secretly collect personal information, adware shows unwanted ads, ransomware locks your files until a ransom is paid, and fireless malware can operate in memory without leaving a trace. These threats are especially dangerous for devices with limited processing power or memory like many IoT that are Internet of Things devices, because they may not have strong defense against attacks. And traditional methods for detecting this malware, like looking at how program works, that is behavioral, and signature based, that is checking for known virus patterns, and heuristic approaches that are using rule based guesses, often fall behind malware changes or new types of appears. That is when new type of attack appears. These approaches can miss clever or sophisticated attacks because they rely on known behavior or patterns. This is where machine learning comes in. Machine learning models can study large amount of system data and learn patterns that indicate malware. They can detect threats more quickly and accurately. And even if the malware is new or slightly different from what has been seen before. At the same time, these approaches are more efficient, requiring less processing power than constantly scanning everything manually or relying on outdated rules. So, to overcome with all such issues, the proposed system is a smart way, that is, the proposed system is designed in a smart way to detect malware using machine learning. It looks at files on window computers, some of which are safe and some harmful, and learns to tell the difference. Before training the model, the data is carefully prepared. This includes cleaning it, making sure that all numbers are on the same scale, and checking how features relate to each other. So the model can learn efficiently. And to make the system faster and more accurate, only the most important features are selected using method called extra tree classifier, that is ETC, by focusing on these key features. That is, ETC is used to extract the important features. So by focusing on these key features, the system reduces the amount of data it needs to process, which saves the time and also memory. While still detecting malware effectively, it will work well. In short, it is a system that is both accurate and efficient. After selecting the most important features in the data, the system trains and tests several machine learning models to figure out which one works best at detecting malware. The goal is not just the accuracy but also efficiency. So the model can run well even on devices that don't have a lot of processing power or memory. And by carefully choosing the key features, by carefully choosing the key features, training strong models, and keeping resources used low, the system is able to detect malware quickly and reliably. This makes it practicable and effective solution for today's cybersecurity needs, where new and sophisticated attacks are constantly emerging. And to make the system even better, to further improve the performance of this project, here we are incorporating ensemble based models, that are voting classifier and stacking classifier. These models combines the strengths of multiple individual models, which helps to improve the accuracy and make the predictions more reliable. On top of that, explainable AI techniques that are specifically LIME and SHAP are added. These tools helps us to understand which features are most important in making a prediction, making the system more transparent. This not only builds trust in the results, but also helps users make better informed decisions based on the predictions. And to make the system easy for users, web-based interface has been developed, which is developed by using Flask framework, and it includes user authentication to keep it secure. Through this interface, users can enter the necessary data and get predictions from the trained malware detection models. This makes the system practicable, allowing people to quickly check for files for malware while keeping the process simple, secure, and accessible. Moving on to the implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented this project. First, we will be importing all the necessary Python libraries for data handling, machine learning, and web development. Then comes data ingestion. So at this stage, the malware detection dataset is loaded from Kaggle into a pandas data frame so it can be analyzed and processed. Then comes pre-processing. At this stage, any missing or null values in the dataset are handled. Categorical variables are encoded to the machine learning models can understand them. Numerical features are standardized to normal scale. Fivefold cross-validation is applied to ensure the model is reliable and avoids overfitting. Then comes feature selection. So at this stage, the extra tree classifier is used with Gini impurity to identify the most important features that contribute to malware detection, reducing unnecessary data. Then comes data balancing. At this stage, if there is a large difference between the number of malware and legitimate samples, undersampling and oversampling technique has been applied to balance the data set and improve the performance of this project. Then we split the data into train and test sets, where train set is used to train the model and test set is used to evaluate the model. Then comes model training. So multiple machine learning models are trained to learn patterns in the data and identify malware effectively. Then comes evaluation. So at this stage, the trained models are evaluated using metrics called accuracy, precision, recall, and reference score, ROC, AUC, Cohen-Kappa score, standard deviation, execution time, and memory usage. Then comes confusion matrix. So at this stage, confusion matrix is analyzed to check false positives and false negatives. Then comes explainable AI. So explainable AI techniques such as LIME and SHAP are applied to understand which features most influence the predictions. And we will be saving the best performing model for the future use. Coming to the part of front end, a user-friendly front end is created where users can enter the data for prediction. The saved model is loaded, incoming features are pre-processed, malware detection is performed, and the result is displayed to the user. So this is how we have implemented, and these are the algorithms used in this project. And this is the extension model, that is stacking classifier. And to implement this project, we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So let's open it. These are the source code files. So let's understand them. Here in this folder, we have the dataset that is used. So these are different files. So we have loaded the dataset from all these files. And here we have model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have files related to CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases in which we have sample files that we will be using in the front end. Here we have app.py file. So this .py file, it contains information related to front end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. That is to be rendered in front end. And here we have notebook file, which is a Jupyter notebook file, and it contains combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. So it is open. Now give the command cd, give the space, paste the copied path and click on enter. Here you can observe current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So just wait for a while. File is being compiled at the backend. Here, this is the address where application has been hosted. So copy this link provided by the Flash framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get signed up first. Click on sign up and enter all the details to get registered. I have already registered, so I'll directly sign in. Click on sign in. Give username and the password. And now click on sign in. So we have logged in successfully and redirected to prediction page of the project. So here you can see multiple parameters. These are need to be given as input to predict the malware. So let's understand them first. First, we have characteristics. This is general properties or flags of the file that describe how it behaves. Then we have DDL characteristics. It is the specific properties related to dynamic link library, that is DDL files, indicating special behaviors or requirements. Then we have major subsystem version. So it is the version number of the subsystem required to run the file. That is the Windows version. Then we have sections max entropy. So this is the maximum randomness or disorder in the file sections, indicating possible obfuscation or encryption. Then we have subsystem. So this is the type of environment or the system where the file is intended to run. Then we have resources max entropy. It is the maximum randomness in the file's embedded resources, which may indicate hidden or suspicious content. And here we have resources min entropy. Minimum randomness in the resources, showing areas of structured or normal content. Version information size. It is the size of the version info included in the file, which may indicate completeness or tampering. Then we have major or version. It's the primary version of the operating system, the file targets. And last we have these sections with min entropy. So this is the minimum randomness in the file section, helping detecting regular or suspicious patterns. So this is all about the parameters. Now let's enter them. So let's open test cases file, open it, open test data. It's opening, just wait for a while. So it is open and here we have two classes, that is 0 and 1. So let's apply filter to it. So let's apply filter to class 0 and click on OK. Let's start filling the parameters, where copy the characteristics, that is 0.05, and we have DDL characteristics, that is 0. Major subsystem version is 0.5 and section max entropy is 0.8. Subsystem is 0.065, and then we have resources max entropy. We have resources min entropy. We have version, information size, major OS version, and sections with copied sections in min entropy. Now paste it, click on analyze for malware. So this given information, it will be pre-processed at the backend, it will be fed to the train model, and then train model will be giving us the prediction. So here you can observe legitimate prediction has been done. That means this case where the transaction has all these details, it seems to be legitimate. So here there is no malware detected. Here we can see analysis completed. This file has been analyzed and appears to be legitimate. That is safe based on machine learning feature influence techniques. And here we have confidence analysis, that is 100%. And here we have accuracy, precision, recall values, that is the model performance. And here we have analysis causes, normal file characteristics observed, standard DDL behavioral patterns, expected entropy values in sections, no resource manipulation indicators. And here we have recommendations. Let's check with the other file. So click on analyze another file. Let's check with this one. So let's start entering them, where characters is 0.005 and we have not copied it properly. Copy it and paste it. And then we have TDL characters and ML, that is major subsystem version. paste it, and section max entropy, subsystem, resource max entropy, resource min entropy, version information size, major OS version, section min entropy. Now click on analyze for malware. So here you can observe legitimate transaction, that is legitimate prediction has been given. So based on the given input, the data has the data is legitimate. And here we have confidence analysis. Here is the model performance, and here we have analysis causes, recommendations. Let's check with the other variable, that is other target, that is class 1, filter to it. And let's try giving this case. So copy the characteristics, paste it, and we have DDL characteristics, and we have major subsystem version, section max entropy, subsystem, that is 0.815, resource max entropy, resource min entropy, version information size, major OS version, and section min entropy. Click on analyze for malware. And here you can see malware has been predicted. So the system is malware, and here the file has been identified as potentially malicious based on the machine learning analysis. And here we have confidence analysis, model performance, analysis causes, and recommendations. So immediate quarantine the file, run a full system antivirus scan, check system logs for suspicious activity, update your security software, consider restoring from a clean backup. So here we have malware, so that is why it is giving these recommendations. Let's check with the last test case. So let's try with this one, where give the characteristics, that is 0.006, and DDL characteristics are 0.061. Then major subsystem, sections max entropy, and subsystem, resource max entropy, resource min entropy, version information size, and then major OS version. Then we have last one, it is section min entropy. Let's paste it. So we have entered all the values, right? Now click on analyze for malware. So here you can see malware has been predicted. So here this is the malware. And here we have confidence analysis, analysis causes, and recommendations. So these are the reports that we have got. And here you can click on view analytics to see the graphs, or else you can even click on graphs. And you can even print the report. Let's click on print report. So it's loading the preview, just wait. So this is the preview. You can see, right? So click on cancel. You can print in this way. Now click on view analytics. So here we have sample outcome graph. The first graph is a sample outcome graph, where on x-axis we have legitimate and on y-axis we have count. Now close this. And here we have confusion matrix. Close it. Here we have accuracy comparison graph, where on x-axis we have all the models that we have trained, and on y-axis we have accuracy. Close it. Here we have precision, comparison graph. Here we have recall, and here we have F1 score, and here we have ROC, ROC AUC, and here we have Cohen-Kappa score, and here we have CV mean, and here we have execution time, and here we have memory MB, and here we have XAI sharp graph. Now close this. Click on sign out. So in this project, we developed a smart system that can quickly and accurately detect harmful files on computer by learning patterns in safe and malicious files. It helps protecting devices from attacks while working efficiently even on systems with limited resources. The system is designed to be user-friendly, allowing anyone to check files easily, and it provides clear insights into how decisions are made. Overall, this project offers a reliable and practicable solution to computers and networks safe from malware. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.